Now we're going to use Simpson's rule to find the estimate of the area. Now a lot of the stuff we need is the same as the previous example, so I've just left what I had in the previous example here. And I'm going to use 10 strips. It doesn't tell me what to use, but that's because we want a comparison with the trapezium rule later in the example. So the formula for Simpson's rule gives us h over 3. Then we have the first and last y's, but then we do twice the even ones and 4 times the odd ones. So what does that look like? So we start with the 0.4 over 3, and we're going to have the 9 add the 97 as before. Now this is y naught. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and of course the 0 and the 10 are already included in here. So twice the even ones, so that's going to be the 18.92 and so on. So all of these ones that have even numbered ordinates. And then we're going to have 4 times the odd ones, so that's the 13.48, and so all of these ones here that have odd ordinates. So that's how we're going to work that out. So let's bring this in. So we're going to have 0.4 divided by 3. Then we're going to have the 9 add the 97. Then we're going to have twice those even numbered ordinates. So those are the ones I crossed here. So 18.92 add 32.68 add 50.28 and 71.72. I think that's 71.72. Let's just check with the above list. The way I've crossed it, it could have been a 9. 71.72. So 71.72. And then we want 4 lots of the other ordinates. So that's 13.48 and 25.32 and the 41 and the 60.52 and finally the 83.88. And we'll execute that, and that gives us 180. We want to find the exact area under the curve now, and then we're going to compare the answers for the trapezium rule and Simpson's rule with that exact answer. Now I'm going to do the exact answer on the calculator just to save a bit of time here. So we were going from 2 to 6, and our function is 3x squared minus 2x add 1 dx, and it's 180. Now the trapezium rule gave us 180.32. Simpson's rule gave us 180. Now Simpson's rule isn't always exactly accurate like this. It's an approximate method. However, we started by looking at a quadratic. And one of the things we discussed is that Simpson's rule approximates across each strip with a parabola. So when we do this, Simpson's rule approximates exactly because it fits the exact parabola to the parabola that we have. So if we did it with a cubic, it would be slightly inaccurate. The trapezium rule, on the other hand, that takes trapezia across the top. Now I've drawn this one in because if I do it individually, you won't see much of a gap. But clearly there's going to be a gap above each strip. That's because the curve is concave up. If it's concave down, then the trapeziums fit underneath. And that's why we've got a slight overestimate here with the trapezium rule.